I'm now going to hand you over to Stian Tongen, who is our K-Spice product champion. And today Stian's going to demonstrate how to integrate K-Spice, Kongsberg's dynamic process simulator, to LedaFlow, which I believe most of you are familiar with, and many of you may have joined the LedaFlow webinar a few weeks ago. And LedaFlow is our transient multiphase flow tool. Once he's integrated the two softwares together, he will then run a slugging case to show how the dynamics and the transients of the subsea impact the topsides. So what we're hoping is at the end of the webinar, you will all have a basic understanding of the workflow to develop an integrated modeling solution. So that's the outcome for this session. So I'll hand it over to Stian.
Thank you, Shane. So if we look at the case we are to look at now, we have our topsides modeled in K-Spice, and we have our feeds coming in. Currently it's just a dynamic process model, not connected to LedaFlow. So we have two feeds, one super well and one smaller feed feeding into a three-phase separator. Free water is removed, gas is compressed and sent for further processing or export. And we have the oil, which is being pumped out with a centrifugal pump. We are now in the K-Spice interface. I'd just like to spend a few minutes going through how this looks. We are now in the model control mode. And in K-Spice then, everything will be clickable. You can click on any line and see the composition feeding in that pipe, the pressures, the temperatures, volume flows, mass flows, all imaginable variables is available here. Also more advanced ones. If you click on a pipe or a valve, you'll get up a predefined faceplate that gives you the possibility to control that valve, open or close. The separator shows you the levels and the pressures and the temperatures. So everything you build in K-Spice comes, if you move into the model building mode. Let's have a look at how we build a model. K-Spice have a vast module library available. And if you take a look at the separator, for instance, we can drop out go down to the basic process tab. We'll add a separator. That's as easy as finding it in the symbols library and dragging and dropping it into the graphic. I'm not going to do that right now since we have already pre-built this model, but we will go into the configuration pane of this separator and we'll have a look at how this is configured. Now this is all default parameters coming in. You can of course add customized parameters to tailor this simulator to your own plant or the concept that you're trying to model. So if we then run the model dynamically, we have that up here in the model control pane. We press play. We are now running the model at about 40 times real time. So now the model is perfectly steady. We can introduce a step change. So I'm now navigating down to the level controller. We have a level transmitter here, which is connected to a level controller, controlling the valve on the downstream, the centrifugal pump. I will introduce a change in the level. Say we move the level down to 1200 millimeters. And you can see how the level controller responds to the step change. You can see we have a small undershoot before it brings it back up to set point. So we'll just bring this back to 1500 for now. So we're back to starting positions before the integration part. So to give you a short overview before we go into the LedaFlow model, I would also like to show you that I've dropped out a lot of pre-made trends in the graphics around here. Any trend can be dropped out just by clicking the trend view and clicking and dragging the trend and dropping it into the graphic. So I've done this here for the separator pressure so that we can easily follow that as we do the integration part. I've also put a multiphase flow meter for the secondary feeding into the system, where I have the 3 phases, the blue being gas, green oil, and the red water. And down here we see the separator level controller and how that is working. That is now back on set point and is steady state. And up here in the top right corner, we have the compressor map. All of this is, of course, readily available. This isn't anything that's custom made. Clicking the compressor, you have the compressor map right there, readily available. I've just dropped that out. So this will be our Topsides model. We will now connect this to a Subsea model, starting at the well and moving into a pipeline. So if we go back into LedaFlow, we can see here that I've preloaded my LedaFlow model here. It consists of a well with a slight incline and then a vertical section, and then out to the manifold. And we have our flow line and the riser, which is have a little bit of a shape, and then coming into the riser itself, and then up to Topsides. This well is consists of the 2 pipes. It has a reservoir inflow. It has a choke valve, a shutdown valve which is fully opened, and a gas lift downstream the production choke valve. So for this demo, I have specially made a slugging scenario where I've choked back the production choke valve so much that we have a too low velocity in the riser, and we create a slugging scenario based on running the riser in an incorrect mode. So this is the flow rates we are then looking at. Topsides the riser. You have the gas flow, the red one here. The oil is here, the green one, and you have the blue being water. And you can see we have some nice slugging going on, moving out to the Topsides. So if we now want to integrate this model to K-Spice, all we need to do is actually go into the boundary endpoint, and you go to properties, and we select couple simulators. This node will then turn yellow, indicating that it will be a connection point to a different simulator. And all we need to do then is to take this model and save it out to a predefined location within the K-Spice project. This has already been done, of course, pre-prepared, so I'm just going to cancel this dialog. And we'll move back into K-Spice. So to add the LedaFlow model into K-Spice, we will now go into the model building mode. We then get all the tools available for building a model. We'll go back into the symbols library, and we'll navigate down to the LedaFlow blocks. And we will select the LedaFlow interface. And we will just drop this into a space where we have room in the model. Now to integrate these 2 models, all we need to do is load an initial condition. So I move back into the model control pane. I select load initial condition, and it will load this initial condition. You can also see here that the LedaFlow interface now has a red color in the top of the corner, signaling that no LedaFlow interface is connected. Once we now press load, the K-Spice will automatically scan for the LDM file and load it up and integrate the two models together. This will just take a short period of time. Oh. There we go. And then you can see the LedaFlow interface turn green, and the two modeling softwares are now fully integrated. So you can now press play, and the two softwares run perfectly in parallel. However, they have no connection points to each other, and they do not interface with each other besides running in parallel. So what we want to do is then remove this secondary feed coming into the three-stage separator and replace it with our LedaFlow model, the well and the flow line. So you go back into the building mode, and we select the feed 2, and we delete this part. And then we are ready to replace this secondary feed with the LedaFlow boundary to indicate that we have a fully connected model towards the LedaFlow model. So creating the Leda boundary will automatically pop up a dialog referencing the available pressure node that we've already configured in LedaFlow. K-Spice is now fully aware of the entire namespace of LedaFlow. So the Leda boundary, it comes in automatically into the model in an isolated state. It's now in a pressure boundary mode. You can utilize this to sync up your models in case you have a very different K-Spice model compared to your LedaFlow models. In case there are a couple of 100 bars difference, you can use this to sync them together. In this case, they're fairly close, so we're just going to go ahead and disable this source mode. And it will tie the LedaFlow boundary into where the secondary feed into the third phase, into where the three-phase separator used to be. Now we have those two. Now we have the two models fully integrated, and the feed from LedaFlow will flow into K-Spice. So if we press play now, we'll move back to model control and select play. We can see that our slugs is starting to come in to K-Spice. We already have a big rise in the flow from the multiphase flow meter here on the secondary feed. And we can see that the level controller for the separator is already starting to work and struggling with keeping the level constant. It will now overshoot and undershoot and constantly be working in order to tackle this new feed scenario. So if we take a look at the third party, the three-phase separator, we can see here that we have pressure spikes. It moves up to 21 bars and then settles down to 20 bars. And it'll stay here for a little bit. We have a low gas flow coming into the system now, so the gas compressor is able to maintain its set point. If we take a brief look at the pressure controller for the compressor, we can see that it is running at 100%. It's running at max capacity, and as the gas slugs is coming in, the gas compressor isn't able to remove all the gas as it is being fed into the system. We can also take a look at the compressor map, and we can see this in practice where the compressor is wanting to push more, but it loses its head, and it has to increase the suction pressure in order to be able to push out the rate that we're required to maintain set point. So this is the only thing we need to do to integrate two LedaFlow models. However, now we are blind to the LedaFlow model and we have no control over it. So the next step then would be to build a shadow version of the LedaFlow model. So we'll bring the K-Spice model back into pause. We'll go into the model building tab. I'll browse down to the LedaFlow symbols. We'll find our Leda pipe. And we'll add this in, and we'll add a representation of the flow line and riser. So this comes in with a default name, Leda pipe 1. We're just going to keep that. I'm going to create this block. With K-Spice being fully aware of the namespace, it now gives us two options in LedaFlow if we either want to represent the flow line and riser or the well itself. For this block, we're going to let it represent the flow line and riser. We'll add another Leda pipe to represent the well. We'll call this Leda pipe 2. And now, since we've already created one, there's only one left available. And K-Spice will automatically suggest the secondary instance that haven't been seen before in the model. We'll also add in the Leda choke valve, which you will find down here under the Leda valves. We'll add this in. If we remember back, we had two valves in the LedaFlow model. We had the shutdown valve and we had the choke valve. So that gives us two options. I'm now choosing just to represent the one valve, so I will just represent the choke valve. And then I will select the HCV here. You can also configure the opening and closing times. We'll just leave all the parameters default for now. And we will also represent our Leda well, the inflow index that we have in LedaFlow. So all of these are now shadow representations of the corresponding models in LedaFlow. And we can run the model at any time. This doesn't need any additional parameterization. So we'll go back into the model control and we'll run the model a little bit. And we can then see what kind of new possibilities this gives us. So the Leda valve will come in with the position that it has in LedaFlow. It's currently at 40%. This valve is fairly choked back, and we have a fairly big capacity in the flow line and riser, which gives us this slug pattern that we see here. Clicking on the Leda pipe, we have a lot of profiles automatically available. We can look at how the pipe looks by clicking the elevation profile. We have our flow line and riser here. We can look at how the mass flow rate is coming, the total mass flow rate is going through the model. We can see here how the mass flow is jumping up and down with the slugs. So now it's a little eradicate. We can lock the y-axis. Set some reasonable numbers here. And we can see how the slugs propagate through the flow line and riser. Once that's pushed out one completely, a new one will start to form due to the low velocity in the riser. We can also bring up any kind of trends from these pipes. We can look at the total liquid volume, for instance, in the pipe. And you just need to right click on any value and display that as a trend. You can enable history to make sure to save these values for later use. And we can see here that we have an increasing liquid amount in the flow line and riser. before there's a plug happening, and it forces and it purges the riser. You can see that this corresponds to the slug pattern. So we'll put the model back in pause. Now the shadow representation of LedaFlow is just hanging in the air. So we can zoom in on this part. We can go back into the model building pane, and we can connect these modules to make this mimic a PNID and give you a more correct visualization of your well. Now these connections that we create here is only for the aesthetics. They don't hold any significance besides that. But it makes the model look a lot better. So now all the modules that we have, that we represent in K-Spice, will give us full control over the LedaFlow model, so that we don't need to actually launch LedaFlow for any particular reason, besides if you want to make any actual structural changes to the LedaFlow model. If you want to change the pipe geometry or something like that. We can now even go into the LedaFlow well index. You can click on this faceplate. You can see here this is a fairly powerful well. It has 500 bars and 100 degrees. So we've choked back this fairly significantly. We can go to the input definitions, and we can change the productivity index, the generic inactivity index, or the pressure or temperature. For the valve, we of course just have the possibility to open or close it. If you want to change the actual CV of the valve, you will have to go into the LedaFlow interface if you want to. If you want to change that. So I'll now transition the system into a non-slugging state. So remember, these slugs are appearing because of a too low velocity in the riser. So we'll increase the flow rate coming from the well. We'll step this up to 60%. And we can see, you will then see that the slugging behavior will continue for a little bit before it settles out and eases into its new position. While we wait for this to happen, we can have a look at the separator pressure. We can see that it has its peaks. That correlates to every gas peak we have from the slugging, and how the compressor moves up and down its performance curve, struggling to get rid of all this gas. So if we move back then into looking at the multiphase meter from the feed 2, we see now that we had one last little purge of liquid coming in before the flows settle out completely. And we see that on the separator pressure as well, but it is now stabilizing a little bit above set point, since the compressor isn't able to handle the maximum flow. We also see the level settling out. Yeah. So this concludes the demonstration of how easy it is to integrate these two tools, and how fast you can be able to train and tune controllers and look at the difficulties you have with slug flow coming into a Topsides model, and you can see your limitations. Making sure that you have a big enough separator, good enough properly tuned controllers, as they can affect each other if one of the controllers starts to oscillate, and that will make the controllers downstream or upstream oscillate as a result.